Kia ora koutou katoa, it's Mrs. Goodson here, and this is an NCEA Level 2 chemistry video about carboxylic acids. In an earlier video, we found out that primary alcohols can be oxidized to form carboxylic acids. That's because the hydroxyl group of primary alcohols is at the end of the hydrocarbon chain. So we're going to look at how to recognize and name carboxylic acids, the physical properties of carboxylic acids, and we're also going to look at the chemical properties or the chemical reactions of carboxylic acids. So just a reminder that we used oxidizing agents to oxidize primary alcohols to form carboxylic acids. We used the dichromate ion, which is orange and turns green, and we used the permanganate ion, which goes from purple to colourless, and both those ions need to be acidified with H+ ions in the solution. So the functional group of carboxylic acids is this group here with a carbonyl. This is called a carbonyl and a hydroxide. And so because this functional group takes up 3 bonds, there's only 1 bond left on the carbon to attach itself to a hydrocarbon group. So this functional group is always found at the end of a hydrocarbon chain. Another way of writing it is COOH, where the R in this case represents either a hydrogen or a hydrocarbon chain or an alkyl group. Sometimes you see it written like this. So COOH means a carboxylic acid. For this one here, we've got ethanoic acid. The R group represents this CH3 group. We've got 2 carbons. Now this carbon here is always carbon 1. So you need to make sure you count that carbon when you're naming it. The longest chain is identified with the carboxylic acid functional group attached at the end. The C of this functional group is always carbon 1. The branches are named the same way as for alkanes or alkenes or other organic molecules. Now, what about the physical properties of carboxylic acids? They are colourless liquids at room temperature, all white solids. They have the ones with low molar mass, methanoic acid, ethanoic acid, are soluble in water. This is because the functional group COOH is polar due to the high electronegativity of the 2 oxygen atoms. The solubility decreases as the length of the hydrocarbon increases. That was the same as the alcohols that we were looking at. The short chain acids have unpleasant smells. Butanoic acid smells like rancid butter. Carboxylic acids have higher melting points and boiling points than hydrocarbons or alcohols due to the increased molar mass and the ability to form hydrogen bonds with each other. So in this diagram here, the dots represent hydrogen bonds, which is the strongest type of intermolecular bonding. Remember that though those are stronger than other types of intermolecular bonding, that's nowhere near as strong as these other bonds, which are covalent bonds between the atoms. What about the chemical properties or the chemical reactions? Carboxylic acids show typical acid reactions, and they can conduct electricity as there are enough ions that are free to move. So they form ions in solutions, and so they conduct electricity. Because they're acids, they turn blue litmus red. So that's a good test to distinguish if a carboxylic acid is present. Use the litmus paper, and if it's a blue litmus paper turns red, then that's the indicator to show that carboxylic acid is present. Carboxylic acids react slowly with metals to form a salt and hydrogen. They react with bases to form an acid-base reaction or a neutralization reaction, form a salt and water, and they react with carbonates and hydrogen carbonates, so that's like our baking soda, to form a salt, water, and carbon dioxide. So in this type of reaction with carbonates, the observation you'd see is fizzing as the carbon dioxide is produced. So let's look at each of these. So when carboxylic acids are in water, they are weak acids. So they are proton donators. So they lose this proton here, which is a hydrogen ion. All right, and that hydrogen ion is going to form a bond with this oxygen and form this hydronium ion, H3O+. And therefore, it's going to leave this as a negative ion. We just put the negative there on the oxygen. And we use this double arrow to show that this is an easily reversible reaction. So this is when you put carboxylic acids in water, they form these ions. They only partially ionize. So they are considered weak acids. Now, because they are acids, they'll react with metals to form a salt plus hydrogen. And the salt these acids form is known as O8 at the end. So ethanoic acid forms ethanoate. In this case, the ion is sodium ethanoate. So that we could put a negative there and a plus there to show that those are ions. So an acid plus a metal makes salt plus hydrogen gas, so H2 for hydrogen gas. The acid-base reaction, or otherwise known as a neutralization reaction, is an acid plus a base makes salt plus water. So we've got ethanoic acid here as an example, 2 carbons, going to react with our base here, sodium hydroxide, to form sodium ethanoate plus water. This reaction here is with carbonates. So we could have sodium carbonate or any other kind of common carbonates, calcium carbonate, magnesium carbonate. So we're looking for this ion here, CO3. So not very soluble, so often we see them as solids. So we're going to react, in this case, we've got butanoic acid. So we've got 1 carbon there and 3 carbons there. So we've got butanoic acid plus sodium carbonate. So we've got an acid plus a base, and we're going to form an ion here, butanoate, or we can do it as a structural formula here, butanoate, and the positive ion is the sodium here, plus water, plus our gas, carbon dioxide, and we would see that as fizzing, all right? So we would expect to see some fizzing when a carbonate reacts with a carboxylic acid. Okay, so those are the reactions you need to know. So we've got acid carbonate, acid base reaction, acid metal reaction, and the fact that they partially ionize in water because they're weak acids. And so those are the chemical properties that you need to know for level 2 chemistry, organic chemistry, and how to distinguish carboxylic acids. Also, we talked about the physical properties and the naming of carboxylic acids. Thanks for listening.